Hello everyone. In this session, let's understand what is copy constructor and what is shallow copy and deep copy, and understand the syntax in detail, and when the copy constructor is getting called, and different types of questions that can come in the interview. Okay. So just to save time, so I have written a few classes. So let's just understand them before we get into what is copy constructor. So I've written a class called address, which has two data members. One is a street, another one is a pin code. And I have written a argument parameterized constructor, which will take street and pin code as argument. Then I have written few getters and setters to get inside these two values. Then I have written a class called person, and this person class has three data members. One is age, other one is name, third argument is address. Okay, address is of type pointers. So just give a careful attention to these data members. Okay, so third one is address, which is a of type pointer. Okay, now I have a person constructor which will take three arguments, age, name and address, and it will assign age, name, address of to these data members. And again I have simple getters and setters, and this is a destructor. Okay, so this is a destructor. Okay, so inside the destructor, what we do, destructor is called basically when the object is going out of scope. Okay, and whatever is there inside this destructor will be called. And usually what we do in the destructor, basically some cleanup activity before object going out of scope. So here what I'm doing, so address is a pointer type. Okay, so if the address is present, then I'm going to delete that address and assign the address to null pointer. This is just basically a cleaning up the memory which is allocated for this address variable. Okay, otherwise what happens, it will cause a memory leak. So let's see this, how this is useful and all these things. So let's go one by one. So here I have created a address object. Okay, address star add app, new address, and then created a person object. Okay, this person object takes values, which is age, name, and the address object. So address object is constructed here. Okay, it is constructed in heap memory. Then I have a person object which takes three argument, age, name, and this address. Okay, so basically this constructor is getting called, and I'll eventually copy or assign those values to age, name, and this address. Okay, so this is what the program is. So let's see whether it compiles or not. Okay, so this, okay, compilation is fine, so no output. Okay, now let's understand what is copy constructor. Okay, so what do we mean by copy? Copy means copying one object to another object. Okay, so the intention of copy constructor is to copy one object to another object. But catch is, while copying the object, okay, while copying the one object to another object, so another object has to be created then and there itself. It means that you cannot, copy constructor will not be called when you already created an object. Let's say example, you have another object person obj2. Okay, and person, and if you want to assign, or if you want to copy the values of obj to obj2, so this will not call the copy constructor, this will call the assignment operator. Assignment operator. Okay, so when the copy constructor is called, copy constructor is called when, let's comment this out, let's keep that in the down. Okay, so copy constructor is called when you are creating another object, let's say object 2, and during the creation of that object you are assigning the value of obj to obj2. So during this, copy constructor is called. So that's why the name copy constructor. So during the creation of the object you are copying another object into it. That's why it is called copy construction or copy constructor. That is when copy constructor is getting called. This is important, is called. So if it is already created object, it will call the assignment operator. While creation of the object, you are copying another object into it. This will call a copy constructor. Okay. Now we understood when the copy constructor is called. Now let's output some of the things here. Okay. Let's say cout obj dot. Let's print the address. Get address. So get address. Yeah, get address here. It will return the address. This member variable. This member variable is of type what? Pointer. So how do we dereference the pointer? With the arrow mark operator. So this address object has data members street and pin code, and corresponding characters are get street and get pin code. So what we have passed for address, so street is mg road and pin code is 560031. So let's try to get that. So I'm using this operator because get address will return me a pointer. Okay, get address and get street. So get street will return me the string. Now let's see what is the output. Mg road. Okay, we'll talk about this in a while, but let's understand that object 2, okay, obj2 and obj is having same value, which is mg road. Let's print obj2 as well. Obj2 as well. So I'll explain why this error is coming. Okay, you see mg road, so both is having the same address. Okay, now let's understand what is happening in between. This is expected behavior, right? So there's nothing surprising element in this here. Okay, so we are trying to copy this object into this object, and we are trying to print in both object we have the same value. Now after copying, what do we expect? So let's say after copying you changed this object. Okay, you assign this object to a new address. Let's say new address. Let's call it as address 1, and the value of this address is kr. Okay, and let's have this pin code 39, and I'm updating obj dot address here. Let's say I'll update obj dot address to address 1. Now let's try to print obj dot address and obj2 dot address. Now I am updating only the address of the object obj, not obj2. Okay, what should happen ideally? So we expect obj dot get address gets to it should have this newly updated value, which is kr program, and obj2 dot get address or gets to it should have mg road, which is copied earlier here, right? So this is what our expectation is. So let's see what happens. Obj dot address. Okay, so this is, I think, okay, the function is obj dot set address. Okay, now you see mg road, kr and mg road. This is the expected behavior, right? So kr has object has value of k of 1, okay, and obj2 has a value of mg4, which is a expected behavior. Now okay, now let's say what I will do. Instead of doing all these things here, so till now no surprises, everything is fine. Okay, now let me write a simple function which is called copy object, and I'll pass person object to this, and then I'll simply call pass one argument called condition. Okay, so I'll explain what is this condition, and what I will do, if this condition is true, then I will create a new object, person new obj equals to obj. So this will call what? This will call copy constructor, right? So as we saw earlier, so let's comment this out for time being. Now I have only one obj object, and in this new copy object, so based on the condition, if the condition is true, I am creating a new object. So let's try to print this object address. So obj dot get address dot get street here, and obj dot get address of get street after the assignment. Okay, so what do we expect? Here while copying, so the value is mgboard, so here also it should have a mgboard. In between, if I try to print this new object, that also should have a mgboard, right? That's what is the expectation. So let's call this copy object function copy object obj, right? Too few. Okay, let me pass the second argument, so let me pass it as true. Okay, so that this will get copied. Okay, so mgboard here also it printed mgboard, here also it printed mgboard, but by the time it came here, it thrown an exception terminate called after throwing an instance of std logic error, and mconstruct null not valid. Why? So let's understand this clearly. Okay, uh, okay, so to understand this, let's try to put it in a diagram. So what we have done, okay, let's say here we have created a new address. So new address, let's put it in a memory block. I put a value as mgboard, and then I put it as pin code 560 560 0 3 1. Okay, let's say the memory address of this is memory is x cross 2 0 0 and 0. Okay, now I'm creating a person object. Okay, let's say I'm creating a object called person. This is a person object, In this person object, while constructing, I'm allocating memory for integer. Okay, let's say the first one is integer. This is integer, and it has its own memory location. Then it is a string. Second one is string, which is a Philip. It has its own memory location. And then third one is address. So this address is nothing but a pointer. Okay. So what is the value of this pointer? This pointer, value of this pointer is 0x2000. Okay. Let's write that here. 0x 2000, which means that this is pointing to this memory location. Correct? This is person object of obj1 of obj, which is created in the main. Now, when I call this copy object, okay, what is happening here? When I call this copy object function is called. Inside that copy object, I'm trying to print at line number 64 obj.getAddress. Okay, obj.getAddress is what? This one, and from that I'm trying to get the street, which is mgboard. Okay, so this address, and in that address I'm trying to get this mgboard. Okay, that's what we are printing here. Now in line number 65, I am passing condition as true. Yes, it is true. I am creating a new object. Okay, I am creating a new object. Let's say this is new obj. Okay, this new obj has again same skeleton. So this new obj, while construction of this new obj, I am copying this obj, the value of this obj here. So what this will have? This will have exact same copy of this. So there is integer which is 20. So here also it is 20. So here also it will be 20. And here also it will be Philip. Here also it is Philip. Then here also it is copying the exact same address, which is 0x 2000 and 0. Okay, which means that this is also pointing at this location only. Now, so far I hope this is clear. So let's explain once again. So first thing, I am creating a address. This is address object. And its memory location is 0x2000. And I'm creating a person object. This is a person object obj, and the value is 20. And Philip, and you have a pointer. Third argument is a pointer to this address. So in the copy object function, again what we are doing in this condition, I am creating a new object, new obj, and I'm trying to copy this object to this new object. So what is happening here? New object is being constructed with this old object. So what will happen? 20 is being copied here, 20 is being copied here, Philip is being copied here, whatever is there here, it is also being copied here. It means that this is also pointing at this memory location. So far this is clear. Now let's understand this part. So let line number 64. Okay, line number 64, when we call object.getAddress, obj.getAddress, this one, and from this one we are trying to get this street, which is it is printing mg about. Now at line number 67, so here obj is copied to new obj. New obj also has all the same data. Here also we are trying to get the address with the new obj. New obj target address is this one. From here we are trying to get the street, which is m0. This is also clear. Now what is happening at line number 69? So why this is throwing an error for line number 69? So let's understand. If you see, we have written this person new object equal to obj in a particular condition. Okay, it means the scope of this new obj is only in this condition, in these two flower bracket. As soon as it hits this flower bracket, this new object is destructed. It means that the destructor of this person class for this new object is getting called. So what is happening when it call destructor of new obj? It will come here. Okay, it will check if the address is there. Yes, address is present. It will try to delete this address. So it will delete actually this address, whatever it is pointing at. So my mg code and this pin code, whatever the address is there, this is getting deleted, and we are assigning null to this. Okay, that's what is happening as soon as it line number 68 is executed. That's what compiler does. Now at line number 69, okay, let's write this. Okay, line number 68. So this link is broken. Okay, and this is this memory address is deleted. It is freed basically. This memory address is freed. Okay, there is no memory allocated at this address right now. Okay, this is freed. Now at line number 69, what happens? Again we are trying to access from this object. We are trying to get the address. It will go here. Okay, but it will from this again it is trying to get the mg code, but this is already freed. Okay, this object is already freed. You are trying to access the value which is already deallocated from the memory. This is a exception. This is a memory corruption basically. So that's why you are seeing an error. You are trying to access a null pointer because I am assigning null to this address. So that's why you see at line number 69 this error. So what do we understand by this? So what we understand is when we try to copy one object to another object, copy constructor is called, and if either of this object, either obj or new obj, if this goes out of scope, it will eventually call its own in its own destructor, and in that destructor, if we allocate any memory for its data member, that will be destructed if we write code like this. So this code is proper, this is fine, but what is the catch here? Catch here is that when we execute, when compiler sees this line number 66, if you see here, there is no copy constructor we have written. Compiler will generate its own copy constructor. In that own copy constructor, it will blindly copy whatever is there in obj to this new obj. So this process is called shallow copy. Okay, this process is called shallow copy. So is that our intention? No. Copy means what? So we should have a completely new set of a memory, and whatever we do in this object should not reflect here, or whatever we do here should not reflect here, right? So that's what is the intention, but that is not the case here. So whatever we are doing to this object, it is getting reflected here. This is not our intention. So this is not the right way how we copy the object, right? So this method is called this way of copying the object is called shallow copy. Shallow copy means you are just reassigning whatever is there here in object to the new object. So what is the problem? Problem arises when we have data member as a pointer, and this pointer is pointing to a memory location. So when you copy this object, we are copying the pointer address. We are not creating a new memory location for MG road and 5600, and we are not pointing there. So ideally, what is our expectation? What we actually want to do is when we copy the object, we want to create a new memory location, and we want to copy this also. Okay, we want to copy what this pointer is pointing at. Okay, so you want to copy this MG road and this pin code 560031. Excuse me for my handwriting. And instead of this link, this should point into this link, which is a new memory location. This is what we expect in the copy, but this is not happening. So what constructor will do? It will just blindly copy whatever is there here, and it will the implication of this is, side effect of this is, it will both will be pointing to this same memory location. So if through this, or either through this object or through this object, if you have done any changes in this object, automatically it will reflect here as well, which is a not a right behavior, which is an undefined behavior. So if this object goes after scope, so this will, its destructor of this object will automatically delete this address, and this will be pointing to a null memory location. This will become a dangling pointer. Okay, so this is not the desired behavior. So this is called a implication of the shallow copy. So this is very, very important. So in your project, when you are writing a class, if you are allowing the copy constructor to be called, or you think that the object is being copied, it is always a best practice whether you copy the object or doesn't copy the object, because the user of your class, you don't know what he will do. So it is always best practice to write your own copy constructor, especially when you have a complex objects, like your class has a structure of the pointers inside your class. It is always better to write your own copy constructor. So I will show you how to write the copy constructor and how to avoid this problem. But now this is the implication of a shallow copy. So this is the undefined behavior. This is very, very important. Okay, now this is copy constructor. Okay, I covered what is shallow copy. Okay, now what is deep copy? Okay, before we actually start writing the copy constructor, let's understand what is deep copy. So deep copy, indirectly I already explained. Deep copy is when you have a pointers like this in your class, you will have to create new memory location and make this new object pointer point to this new memory location, so that you don't have a reference to the old memory location. It means that this will become, these two objects become independent of each other. Those are not dependent of each other. Whatever you do in this object, it will not reflect here, or whatever you do in this object, it will not reflect here, right? So that is the advantage of deep copy. Okay, so when you write your own copy constructor, make sure that you do a deep copy so that such problems will be avoided. Okay, so let's just get into writing our own copy constructor. Okay, so I will show you how to write our own copy constructor. What is the syntax? So syntax of copy constructor is class name. Okay, and then we have a const. This type of the argument is person. It's a reference type. Let's call this as a obj. Inside this copy constructor, let's try to copy this object to this one, this current object. Okay, this current object is what? Here, new obj. New obj is a current object. For this object, this obj we are passing. So here whatever we are argument we are taking is nothing but this obj, and new obj is the object is in construction. Okay, so that is when copy constructor is getting called. This is copy constructor. Okay, I hope I am clear. So how this is inferred is this new obj, okay, is a new object. This object, new object that is being constructed, and this, what is this parameter? Parameter is nothing but whatever is we are trying to assign. Okay, that is this one. Okay, that's how it is inferred. That's how compiler will infer. So always remember that for the current object, whenever you have a current object means this object, when you're inside the class, you will have access to the this pointer. So this pointer is always pointing to its current object. Okay, if you want to refer these elements inside your class, you can use this pointer. This is not necessary, this is optional, but it is a good practice. Or if you want to make things very clear, you can use this. So this is a pointer which is pointing to a current object which is being constructed. So let's write this of age. Okay, I will assign object dot underscore age. So I'm copying object's age into the this object's age. Then what we have, underscore name equal to obj dot underscore name. Then what we have, this of address. We have address. Okay. This is a address is again a pointer. So let's create a memory. If we again directly do this obj dot underscore address, so this will be still a shallow copy. Even if you write your own constructor or own copy constructor, if you do this, it will be a shallow copy. So this is very important. When you're writing your own class, you should not do this. You should not do this shallow copy, especially when you have complex objects or pointers in your class. Okay, avoid this. So this can be asked in the interview. What is the difference between shallow copy and deep copy? When the shallow copy happens, when deep copy happens, what are the implications of shallow copy? How do we avoid shallow copy? All these things. Okay, instead of doing this, what we can do, for this we can, this is a address. Okay, this is a address is a pointer of type address. So let's create a new memory of this address class. Okay, while creating, what parameters is expecting while creating this address object? It is expecting street and the pin code. Okay, while creating that object, address, new address, let's pass street and the pin code. So from where we have to pass street and pin code? We have to pass it from this object, right? So whatever the object is, we want to copy. So object also has obj dot underscore address, and in this address we have a get street method which you can use to copy, and the second parameter is pin code. Object dot underscore address of get pin code. So I hope I am clear with this. So we are creating a new address object, which is nothing but this. We are calling this constructor, and we are passing street and pin code. So this street and pin code, I am getting it from the object which is from which we are copying. So from this object, basically nothing but this one. This object is being copied. Okay. Okay, so before this, let me tell you one more thing. Okay, so let me comment this. So I wanted to explain you one more thing. Let's say you don't have all this, and what is expected? It should be a clean code, right? You're not copying or doing anything. You see here, double fee detected. Okay, this is another implication of shallow copy. This is a second implication of shallow copy. What is happening here? Let's understand this also before we move into the writing of one copy constructor. Here, in this copy object, we call this object, okay, obj. Once we call this object, uh, this is nothing but from here to here. This is calling the copy constructor only, because here this is an existing object and this is an object which we are creating. So this will call automatically the copy constructor, which is a default copy constructor, which is currently not there here. So this will call a copy constructor. So new object is created. As soon as line number 80 enters, this object will go out of scope. So when object goes out of scope, what happens? It will call its destructor, right? So when it calls a destructor from this object, this is consider this person obj is this new object in this case, and this object is this one. Okay, now this is not the old case, this is a shallow copy case. Let's this address is still pointing to this old address only. Now as soon as line number 80 hits, so this object, okay, basically this object goes out of scope. When it goes out of scope, it will call its destructor. In the destructor, we are deleting the address. So what we are doing, we are deleting this address memory, right? Okay, fine, this is fine. So this new object is having reference to this address that is being deleted, that is valid. But when this object, okay, at line number 97, when this object is going out of scope, this object will also call this address. This address has some address, okay, which is pointing to a memory location, but that memory location is already deleted by some other object. Okay, this has become a shared memory location. This is already deleted by another object, and we are still having access to, or still we are pointing to that memory location which is already deallocated. Because of this, what happens? This object does not know this is already deallocated. It just have the memory address, valid memory address, but in that memory address, nothing is there, right? It is null pointer. And what we are doing, we are trying to delete that address. Okay, we are trying to delete this address, which is already deleted by another object. That is why it is telling us we are trying to do a double free. Okay, it is a compiler is smartly detecting that it is we are doing a double free. Okay, this is another implication of shallow copy. Okay, now let's uncomment this. Okay, let's uncomment this copy constructor. I'll explain why we use const, ampersand, all these things. So before that, let's get rid of this problem. Okay, till now I have not done any copy constructor here. This is only one copy being called from here to here. Okay, let's see if this error is gone. Yes, so this is mg word is printed here, mg word is printed here. Okay, because now we don't have link to this. I'm creating a new memory location here. If you see in the copy constructor, I'm creating a new memory address. Okay, this is a new address I'm creating. I'm copying whatever is there here to this one, from here to here, here to here. Okay, so this is what is happening. That's why you don't see double free error now. So individually, when each object goes out of scope, first when this goes out of scope in the from the copy object, when this object goes out of scope, this will delete this one. So this is still unaffected, and on the main, this object, when it goes out of scope, it will delete this one. So this is already deleted and it does not have any reference to this old deleted one. It will have its own copy. So deep copy is nothing but it will have its own copy of the object. Okay, so I hope this is clear. Now one problem is solved. So let's understand this as well. So what happens here? So when I try to create an object, earlier what happened, when this new object went out of scope, this object is also getting affected. So when this object goes out of scope, this was earlier it was pointing to this and this was deleted, and this is also getting affected, right? So it was having a logic error, right? Because it was still pointing to this memory location which is already filled. Now with this copy constructor, what we are doing, we are doing a deep copy. So this reference is not there, and let's say where is this reference is not there, right? It is copying to this value is are copied to here, and these two are completely independent object. So that's why you see in the output mg vote and mg vote, right? Okay, so this is the advantage of deep copy. Okay, now if even if you assign any other uh, value to this newly constructed object, this will not affect this object. Okay, let's try to see that. Okay, let's create a new address object. New address, let's call it as um, kr1, and let's call this 34. Now the value of when we try to print this should not change, only this should, the new object should say, new object value should only be updated from mg4 to kr1. This should not change, that is the expectation. mg vote, mg vote, mg vote. Why all are having mg vote here? Address is okay. I have not set it. I have not set it yet. Let's set new object to this address. New object dot set address to this new address. Now this has to differentiate this. Let me prefix with new object so that we can clearly see it. Okay, old object is mg vote. Here it is printing mg vote because this is printing here, so pointing it here. And the newly created object, initially when you copy it, this will also have a mg vote. Okay, let's see that also. Initially that also has mg vote. Then after this line number 78 and 79, I am assigning new address to this newly created object, and this new object will have new value which is kf1, and again when it goes out of scope, this old object is still pointing to this old address location only. So this is not altered, this is not corrupted. Okay. Let's see the output. As you see, this is old object, and both the new object, first old object is having mg vote because this object is being copied here, and the values of this address is also being copied here because of the way we have written the copy constructor. Then when we try to alter this object, new object, and we try to change the value of this address to the care form, only it will update here because this is a independent link. Okay, so it will update only here, and as you can see the new object value is mg, sorry, care form. Okay, and again if you see the old value is not affected. So this is the copy constructor and importance of shallow copy and deep copy, and why we have to write our own copy constructor. Okay, so I covered all these things. So let's cover one more thing here, which is very very important, the syntax of copy constructor. So you might have seen here, contact person ampersand obj. Okay, as I said here, this obj is getting parameter in this person obj. Okay, and this one is nothing but a this pointer of this object. Now let's understand why we have to write const, why we have to take a reference, means ampersand. What will happen if I don't put ampersand here, or what will happen if I don't write constant here, right? So this can be asked in the interview. So let's clear this, clear all the driving. Okay, let's understand why we need a ampersand. Okay, in order to understand, let's see what happens when we don't have ampersand, right? So let's experiment this. When we don't have ampersand, what will happen? Can we guess? Can we take a pause and guess it? Okay. Annually consider probably meant person, const, person, ampersand. First of all, it is not, it is throwing an FF itself. Okay. It is not allowing and saying that it is an invalid constructor. You probably meant person, const, person, ampersand. So now there is a strict check that the copy constructor syntax has to be like this. In older compiler, this was not the case. It used to allow this, but what was happening in the background is it will be going in an infinite loop. Why infinite loop? Let's see this example. When you create an object and when you call this function, this object is being copied here to this object. So what is happening this time? That time it will call the copy constructor. So copy constructor is what? This one. Let's say you don't have an ampersand here. So it will call the copy constructor. In the copy constructor, again what we are doing? Again this is nothing but a copying an object. So again it will call the copy constructor. Same copy constructor. Again it says that, oh, again it is a copy. I have to call a copy constructor. Again it will call the same copy constructor. So it will keep on calling like this recursively till it the memory till it runs out of the memory. It is a continuous infinite loop. Okay, so that is the biggest reason why we need to use ampersand here. So when we use ampersand, what happens? We are not copying, we are referencing. Okay, so when you refer, what happens? When you use reference, it will not be a copy, it will just an alias to the same memory address. So we are referring to the same memory address, we are not copying that one object to another object. So this is one reason why we need to use ampersand. Okay, so ampersand is used to avoid infinite loop of copy. Okay, this is one reason why we need to use ampersand. Then why we need const here? Okay, why we need const here? So one reason, one straightforward reason is when you are constructing an object from another object. Okay, when you're constructing an object from another object, you don't want whatever is being copied here, okay, whatever is being copied or whatever is you are passing here, this object should not be changed. It has to be read only. Otherwise what happens when you're copying, if you allow or make it non-constant, okay, this object can be altered inside this constructor, which is a wrong, okay, which is against the rule. So let's say you have non-const here. I doubt it will compile. Let's see what happens. See, cannot bind non-constant L value reference to type person to an R value of type person. Okay, so the compiler itself does not allow because this is not valid. This check is there now. You have to use const here because you don't want this object to be modified inside this, because you just have to use it as a read only to copy the members in this object to this new object. That is the reason why we need to use constant. Okay, so another reason why we need const is, let's say you want to create an object from a temporary object. Okay, let's understand this. Let's say you have a function, okay, function called person, return type is person, fun, okay, and this will just simply create a person object, okay, person object. Let's pass the parameter here. Say age is 30, name is Max, address is this address, and return obj. You have a function like this which will return an object. Now let's say here, let's comment this out. I'm creating another object, person obj2 equal to this func. Basically, somewhere in your project you are calling a function which will return an object, and that object you are copying to obj2. So this will also call a copy constructor, right? Because obj2 is still constructing and fun is evaluated, and when it is evaluated it will return the object. So when it returns the object, this value of this object is getting copied to this obj2. So this will eventually call this copy constructor. When it calls a copy constructor, what fun returns? Fun returns an object. Okay, fun is not an L value. Okay, fun is not an L value. Fun is an R value or temporary value. After this line number 98, the return value of fun is not exist anywhere. It is just copied to obj2, but individually it does not exist anywhere. When you have such a thing, when you have such a temporary variable getting copied to obj2, this has to be a constant. Okay, because you cannot modify this temporary object. These temporary objects are always constant. When it returns here, it is always a constant. This cannot be modified. That's why the copy constructor enforces to have a const here to allow or to accommodate such signature or such use case. Okay, if you compile this, no matching function for call to person max address. What happening here? Address edit, have new address. This is fine. New address. What is there? One number 88. Person OBJ. Okay. ADDR. This is address. Hmm. Address tab. Address. What it is telling? Expects one argument, but three provided. Person. Oh, okay. I think it has to be double quote. It is considering it as int. Okay. So this is fine because we have a constant here. That's why it is working. If you don't have a constant here, if compiler does not enforce constant, if you see old compiler, this is a new compiler, it automatically enforces the constant here. But in old compiler, without constant also we can write a copy constructor that would work when you don't have such a statements. Okay, it used to work for statement like this, but when you encountered such a statement, when you have function returning an object which is a temporary object, okay, it does not have any existence after this line, and this has to be constant. Okay, so that cannot be a non-const. That's why a copy constructor has const as its signature in the signature. Okay, so there are two important things here. One, why we need to have a reference, and the one is why we need to have a constant. So one default thing is with a constant you will not be able to modify this object because this is a reference object. Reference object should not be modified. It means that whatever you have caller is passing, it is pointing to that same object only. It should not be modified. That's why that is one reason why we use const. Other reason is to allow such signatures, okay, such statements. For a temporary object to be copied, we need to have a constant. Okay, think I covered all the things here. So these are very important concept in copy constructor, and the signature of the copy constructor, why we need to have the copy constructor, uh, what is the best practice, all these things is very important. So always remember, the thumb rule is when you have your own class, write your own constructor or own copy constructor, especially when you have complex objects or pointer objects in your class. So you need to do a deep copy always to avoid problems like memory corruption. Okay, so that's all about copy constructor. See you in the next lesson. Thank you.